Hello class, this is a video tutorial on nonlinear simultaneous equations. Similar to linear simultaneous equations using substitution, but this requires nonlinear equation solving methods. So I'm going to be doing two examples here, perhaps maybe four depending on the length of this video, but here we go. So when it comes to solving these simultaneous equations using substitution, we would like first to have the expressions, or at least one of them, having a single pronumeral as the subjects. So in this case, they've already set it out that way. They're both equal to y equals something, and this is what we want. So now I'm going to label these equation 1 and equation 2. Obviously, you can number these in any way you like, so some people do it like so, 1 and 2, or whichever way you like. No, let's keep it simple. 1, 2. Now, I'm going to write down what I'm going to be doing. I'm going to substitute equation 1 into equation 2. By that I mean where y is equal to 3x plus 12, I'm going to substitute that value here. Okay, so now it's going to become 3x plus 12. So there's my substitution. I took that one and put it here. And I'm going to let this equal to the rest of the second equation. So x squared plus 9x plus 20. And then from here, we're just going to solve this quadratic equation. So I'm going to move everything to the right. So I'm going to get 0 is equal to x squared. I subtracted 3x from both sides. So 9x minus 3x is plus 6x, because 9 take away 3. And then 20 take away 12 is 8. So now we're going to solve this by factoring, or whichever method that you would like. For this, I'm going to solve this equation by factoring. So we need two numbers that multiply to 8 but add to 6. Okay, so the factors of this are going to be x plus 2 and x plus 4. I'm just going to move this to the right side just to make this a little bit neater. And from here we can solve this quadratic equation. X plus 2 is equal to 0. X equals negative 2. So that's one x solution. We'll find the other one. And here's my other x solution. But now the solutions that we require come in pairs. So I'm going to now substitute these values into one of the equations, preferably the easiest one. So now I'm going to substitute x, well, you know what, I'm just going to substitute solutions into, let's say, my equation 1, because it's the easier one. You could substitute it into equation 2, and you should get the same answer. So my equation 1, let me rewrite it here so I can see it. Y equals 3x plus 12. And now I'm going to substitute x equals 2 into this equation. So we get y is equal to 3 negative 2 plus 12. This gives me negative 6 plus 12 equals 6. So this pair of solutions on my left side, the solutions are x equals negative 2, y equals 6. And because it's x and y, I can label this as a pair of coordinates, so -2 and 6. And I could plot that in if I'd like to. Let's now take the second solution, x equals -4. I'm going to substitute this into this equation. We get y is equal to 3 times -4 plus 12. This gives me -12 plus 12, and this is going to be 0. Y equals 0. There's my next solution. So this pair of equations on the right is x equals -4 and y equals 0. So, and lastly, just writing this as a pair of coordinates. This is only valid if we have x, y coordinates. Anything else, we can just label it as this step here. So here are my two solutions. Sorry, two pairs of solutions, because these solutions must always come in pairs. Let me just highlight this so we can finalize this question. All right, let's do one more question. I'm gonna go a little bit faster now. Here we go. For this one, we need to rearrange the equation so that we get a subject. So for this, I'm going to rearrange the second equation so that it looks like a y equals something. So I'm going to let y be on this side. I'm going to move the 4, gives me -4. I'm going to move the x to the other side, giving me -x. So here's my, I'm not going to use this equation, I'm going to use this one. Okay, so now I'm going to substitute 2 into 1. So where y is here, I'm going to substitute this expression into there. Okay, so it's going to become x squared stays the same, plus here is where my y is supposed to be, but I'm putting brackets in because I'm going to place this into there. I'm substituting it, so -x minus 4, just cleaning this up. And this has a squared, so squared equals 16. Okay, so now I'm going to expand this group. X squared plus square the first, square the last, 2 times the product of the middle, so it's going to be plus 8x equals 16. Factorize, collecting like terms, these two will add, plus 8x. Moving everything to one side, I'm going to subtract 16 here. This will give me 0. Subtracting 16 on both sides. Factoring this left side, we can factor out a 2 and an x, giving us x plus 4 equals 0. And from here we can take the two solutions, we can let this factor equal 0, so 2x equals 0, x equals 0. That's one x solution. We can now factorize this one and let that equal 0, so x plus 4 equals 0, x equals -4. Here are my two x solutions. Now we're going to substitute this into my second equation because it's the easier one. So sub this into number 2. So we have y equals -x minus 4, so it's going to be -0 minus 4. That's just 0 minus 4. That's y equals, not 4, not 0, sorry, it's -4. So lastly, my solutions are x equals 0, y equals -4, or 0, -4. That's one pair of solutions. And this one now, I'm going to substitute into my second equation, y equals negative of negative 4 minus 4. That's positive 4 minus 4, which is 0. So lastly, my solutions are now negative 4, x equals negative 4, y equals 0. Putting this in a coordinate form, those are my solutions. Giving them a highlight. And there we go. So I hope that made sense to you, and it gave you an insight into solving simultaneous non-linear equations. Okay, so hope to see you in the next video. Best of luck.